a range of towering mountains, and 5,700 kilometers of sea coast contain within their confines a land that is as diverse in its geographical features as it is in its people, flora and fauna. This land is India, a vast subcontinent of surpassing beauty and infinite variety, filled with the unexpected, abounding in surprises. India, an ancient land, diverse yet homogeneous, progressive but still progressing with the march of time. Plans for progress call for an intimate knowledge of the country. Every salient geographical and man-made feature of the vast, complex and diverse terrain has to be noted and recorded in the form of maps. Maps are the stepping stones to planned progress. They are the basis of every project, urban or rural. In fact, maps are a necessary adjunct to almost every sphere of human endeavor. They are necessary in the fields of industry, agriculture, communications, tourism and transportation, as well as for the defense and internal security of the country. The task of collecting and collating all this information and finally presenting it in the form of maps is carried out by the Survey of India. The Survey of India are the official map makers of the country and the only organization that caters to its vast and varied mapping needs. The history of the Survey of India is the history of modern surveying and map-making in India. It dates back to the 18th century when intrepid surveyors performed the onerous and often dangerous task of exploring and charting the then unknown territory. Surveyors like Lambton and Everest laid the foundation of surveying in India on scientific lines. The Survey of India is the recipient of this heritage, which confers on it the pride and responsibility of being the oldest department of the Government of India. In India, maps for everyday use are inexpensive and freely available. The sale price does not reflect the dedication, hardship, toil and perseverance of the field survey personnel who collect, identify and confirm the survey data contained in every map. But what is a map? In simple terms, a map is a two-dimensional representation of a portion of the Earth's surface. It depicts the various natural and man-made features of the area in their correct relative positions. This information is shown within a framework of lines which represents the lines of latitude and longitude within which the area lies. Maps are drawn to various scales to suit different needs. Large-scale maps display features in greater detail than ones drawn to a smaller scale. For instance, a geographical map drawn to a scale of 1:15 million, which is a small scale, indicates places with dots or small circle. Whereas a topographical map drawn to a larger scale, such as 1:50,000, enables the map reader to identify his position on the ground in relation to adjoining features. Maps are also made for special purposes. They portray particular features such as roads, railway routes, city streets, or places of interest to the tourist. The first step in map making is to determine the exact positions in terms of latitude, longitude, and height above mean sea level of points evenly distributed in the area to be mapped. These points are known as Geodetic Triangulation Stations, or GT stations. The network of GT stations is called Basic Geodetic Control and is available for the entire country or any portion of it. The points used in basic geodetic control work are not just theoretical indications on paper, but exist as physical positions on the surface of the land. This is a GT station. Like other GT stations, it was established a long time ago with the use of conventional survey instruments such as theodolites, chains, and steel bands. The control network, however, is now being refined with the aid of modern satellite-based techniques. Distances between GT stations vary. They may be anywhere from 16 kilometers to 150 kilometers apart. The empty space between the GT stations is further filled by a second-order control network. The control points in this secondary network are referred to as topographical stations. With the help of these secondary points, the relative positions of various features on the surface of the land, such as roads, railways, canals, rivers, and other aspects are located. Relief is brought out by contours. They are made up of lines which join points of the same height above mean sea level. Topo stations are used in conjunction with the classical plane tabling method of surveying. The Survey of India employs the latest techniques and instrumentation for surveying and mapping in conjunction with traditional field surveys. Aerial photographs and computer-based photogrammetric instruments are used to conduct second-order control work, the plotting of details and contours. Aerial photographs are taken with the help of a specially designed camera mounted in an aircraft. The aircraft itself has to meet very rigid specifications to enable it to carry out this type of work. Here we see an aerial photograph and a map of the same area. This picture was taken via a satellite. Such pictures are also used for updating small-scale maps. Once the basic data required for a map have been obtained, the next step is to convert this information into a presentable cartograph or a map. Till very recently, the Survey of India followed conventional methods for making fair drawings. Such drawings had to be photographed in order to create a negative image. The negative image was then transferred onto a printing plate, which in turn produced positive impressions in printing. A more advanced process called scribing is now being generally used. Scribing involves etching on coated plastic sheets with the help of needles and graves of different thicknesses. Each of these tools has a specific use. The advantage of scribing is that negatives are obtained directly. Photography is not necessary as an intermediate step. Scribing is a quicker process than the conventional fair drawing method. It also produces finer results and costs less. It enables the Survey of India to provide a better quality map cheaper and faster. One of the latest advances in map making is automated cartography. In this system, graphic data are received, converted and stored in digital form. The data can be called up and translated selectively at different projections and scales to produce fair-drawn originals directly on scribed sheets. The fair drawings are transferred to plates for printing. The high-speed rotary offset printing machines used by the Survey of India are capable of printing 2 and 4 colors simultaneously at speeds of between 6 and 8,000 impressions per hour. This is the end product, a map for the user. The Survey of India produces a very comprehensive selection of maps. This map and others, each with a use of its own, can be purchased from any of the map sales offices of the Survey of India. Three-dimensional maps are a comparatively recent innovation. They are more useful than the conventional two-dimensional maps in many realms of activity. The Survey of India has evolved its own capability in this type of map production. It is now producing three-dimensional maps for different uses. The techniques and equipment have been developed and manufactured indigenously. The Survey of India has established a unique training center in Hyderabad with assistance from the United Nations Development Program. This establishment is the only one of its kind in Asia. Set in spacious grounds, the well-laid-out campus houses the training center, the headquarters of the Research and Development Cell of the Survey of India, and a pilot map production department. The training center offers a variety of courses: basic, comprehensive, and specialized. These courses cover all the survey disciplines. The center caters not only to the training of its own personnel, but also to cadres from other central and state government departments. On the international front, India follows an open-door policy in accepting trainees to the establishment. Many African, West Asian, and Southeast Asian countries have availed themselves of the opportunity.
Satellites, computers, and automation are changing the technology of mapping steadily. However, in spite of these changes, considerable part of our activities continues to be field-oriented, and during the field seasons, our surveyors are spread over almost the entire country, from the high Himalayas to the coastal area, from thick forests of Tarai to deserts and marshy land. The demands on surveyors' endurance and initiative are many and varied.
A rare esprit de corps, combined with a blend of traditional ideals and contemporary technology, accurately defines the oldest government department, the Survey of India.